Okay. Oh, it's starting. Nice. It's my first time live streaming on YouTube, so hopefully everything goes good. Yeah, it says I'm live now for 34 seconds. Oh, sweet. Oh, nice. Sweet. Okay. Sorry, I'm just like, it's my first time live streaming, so anyone that's actually watching this in the archive, sorry about the, do apologize about the few seconds here before I get started. I'm just going to paste in a few links here just to give some people a live stream. So I guess I'll explain what I'm going to do here. So this is a live stream for the Hacker's Edge online. Actually, maybe I'll just go to the. I'll just bring up a shell here for I can kind of. Oops. Okay, so this is for this here. So if you telnet, or you can go to the website, to the website as well. If you go to here, this is the development what I'm doing right now. So I'll be live streaming the development of this here, so you get to see how it all works and that. Oh, forgot about that. Okay. Anyways, I'm gonna put that over there because I have to start up. Actually, I'll keep this. I'll keep this here for now, just to, just for that's there. Just give me a moment here. I'm just gonna put the live stream out. Hacker's Edge development. Live stream. Live stream. Okay, perfect. Okay, and I'm just going to quickly go to my... Actually, no, I won't post it on Twitter yet. I'll just do the Twitter post afterwards because this is my first one, so I really don't want to get too much attention right now for this. So, okay. Okay, so let's get this all started here. So I'll go through my usual development, how I usually start everything up. So I got to start up on my servers and everything, of course. So that's the web server, and then now we have to start up the beautiful back-end servers. So Python debug server. So for it, was the debug image. These are things you don't see as a player, obviously, or you won't see normally. These are all debug logs as well. So like, there's a lot of new things I'm putting in development right now, including EM6502D-D. So I'm going to restart the main game server because if you look here, if you look at the game server here, you'll notice Hypervisor is trying to make a connection to here, but the daemon's not obviously up. So because this is part of the economy system here. So starting economy, and the economy obviously fails to start because it needs to connect to that certain server there. So let's just restart that up. There, now you can see here loading CPU state and that. So, and a majority of this project is open sourced right now. Parts are going to be closed source, and of course there's going to be the in-game stuff, which I'm going to have as closed source as well. So let me just go back to my YouTube here, and I will be taking answers as well. So if you're in the chat and have any questions about what I'll be doing in that, just please feel free to post anything out. So with further ado, I am going to actually go into the actual development here. So let's go. I want to go to, because we have under ASM, we have my beautiful Hacker OS code here. So I want to open up this in my editor for you guys can kind of get an idea on how the OS is being put together right now. So I'm going to move this out of the way here. So here's my Hacker OS code here. Actually, you guys can't see my file list. I purposely made it for I can hide what I need to hide. So where's my make file here? So everything is done through this beautiful make file. This make file is not actually open source or in the public right now, but it's a good example on how things are put together right now and how building everything is quite easy. So I want to give you a quick example on how easy it is to build the OS. But first, actually, I got to log into my development server. So actually, put that back there for a second. I got to open up a new window here. Okay, so first I got to telnet into my local host development server. Oh, the lag's not too bad. I'm actually watching the video here on my other screen, and it lag's pretty good. Okay, so yeah. So on my development, I actually have quite a bit of hosts, as you can see here. So if I believe, actually, I wonder if I press F5 here. Let's see if this is the right one or not. I don't know. I think 2 is the right one actually. So if I go to my yep. So right now it's using. So I created a device that makes it easier for development. So under /temp, I have a debug.fs directory. So when I build my OS, it actually automatically dumps everything in there. As you can probably see from the code, there's references to /temp/debug.fs. So let's go back here, and I'm just going to halt. Actually, I can't halt it easily here. I gotta actually. Gotta do actually you can do I think it's F4, my key, yeah, F4. I have some macro hotkeys that I can press. So anyway, so let's so I'll go through actually I gotta bring this one back. Okay, let's see here. So I want to do a make clean here. So this will clean up everything. So this cleans up all the files. These are just the basic files now. So now if I go make I can go make actually, I can make boot sys. Sys will make boot sys, and you'll notice that it works perfectly there. And I can go make kernel sys. Ta-da! Kernel sys now made. If I do a full make, I'll actually have to probably do a make clean again because it checks it in order there. So as you can see here, it does all my compiling and everything and sends everything off there. But I want to do a make clean again and do a full make. It will fail, I believe, at one point here. No, actually it won't. I thought oh no, I know. Sorry. It's been a couple days since a couple weeks since I built this. So I actually have a few things. I had to go make OS. This should actually build everything. There, make OS built. Oh, interesting. Oh, yeah, that's the clear program. Yeah. The clear program doesn't really matter too much. That's the last one I have there in my list, so it doesn't matter. Because the clear program, I was playing around with not having having the header generated differently, so that's what I was playing with there. But yeah, so as you can see, it builds everything beautifully here. So you have all the files being built. It builds the basic OS. So you have rm, hebin, and everything else here. You have all those files. Actually, I'll need hebin later on for something, so I go hebin.o because a lot of my things are dependent on that. So I'm going to put this back over there for a second. And now if I press F5, I'm a new bootloader. I forgot about that. I have a new bootloader I was testing out. And if I go ls, these are all the files that it compiled. And now I'm running the OS that I just built together there. So we'll put that back for a second and explain a little bit what's going on here. Let's see here. Yeah, so where is... That's the boot ROM there. Booto, debug.fs. Okay, actually something that might be interesting to actually show is this is another part actually that's not shown in the... I don't actually have in the public either, which is kind of a neat ability for anyone actually wants to watch this and see the back end stuff. So I have a few different config files. As if you notice here, the boot ROM has HEROM. This one actually is publicly available. So this is the HEROM config. This just defines a very, very basic flat system where you have the ROM, you have your RAM locations, etc. for your assembly. And then we have the HEBoot is the next one that's used here, as you can see. HEBoot is pretty basic as well. It's only a RAM position, it's not really ROM, and then you define all your pages. Now the more complex one, the one that is the most interesting to see, is the HEKernel config files. So if you look here under kernel, you see that I compiled the kernel. The kernel is HEKernel config. We have a kernel map, and then we do that. I might actually open up kernel map here because kernel map's actually an interesting file. I'll show you it after that. I'll bring that up after. Okay, so So we have a 0 page, which we start at this, we allocate this, we have our kernel that starts at this location, we have our file driver, we have our network driver, we have our shell that starts over here, and then our shell data starts over here. This is the exact same layout that I have specified on the website through the memory mapping, if anyone went there to take a look. But the kernel outputs is the file that I output in the make file, and then we have file IO.sys, network driver sys, shell sys, and then this. This is basically how I generate the kernel and all the drivers and shell program all at once to make everything simpler, and everything can easily reference each other during the assembly process. So then we have our startup code in our main segment, as you can see, and there's everything else, right? So. And then, of course, down here we have a couple symbols, IO table, and our JSR table I define here as well, because it's quite helpful. So here is the kernel map. This also isn't available. This is the kernel map. So you can see here we have kernel.o file, which gets built, and we have where our code locations are. We have the file O, and we have our other files here. They get generated as well, along with the process. And then we have, of course, our segment list, which, of course, displays exactly what you saw over there and displays the locations and memory of the code. So startup code is located here, our actual runtime code, and then the read-only code, and their file driver, network driver, shell, etc., right? And as you can see, I make use of exports and everything as well. You can see all my exports here, file load, print, shell int, and quite everything else there. And, of course, all the files. So that's the kernel map that gets generated. So, and today I was actually going to do a few updates in regards to. Well, let's take a look at my Trilio board here. So I have a board set up. If you go to the Discord channel, there's a link to this board here on Trilio. So as you can see, there's quite a few things that I was working on. So right now to do, I worked on part of this. There's a bug some reported that I still have to look into and fix eventually. I want to be able to create an easy language I can compile into assembly, and then they can assemble that code into machine code to use within the game world. And then, of course, I was working on this for a while. It's an idea I want to create eventually is a real world internet to in-game network bridge. So you'd be able to basically connect to your in-game hosts from the actual internet using a certain port and API. So you can create a bridge essentially. And then there's a bug someone reported here as well. So it's an empty host of S. I got to create that eventually. So today, yes. So that's what I was kind of working on. There's a weird bug going on with my SEI CLI code there, where my interrupts are kind of acting up a little bit. So I was thinking of looking at resolving this. I actually wrote lots of comments the other day and see if I can move this over, make it fit. So. This is all on the Trilio page if you're curious about reading this, but I'm not going to go through too much of this. But there's a suspected bug that SEI and CLI were swapped, or there's something weird going on. But then I figured out that it wasn't actually swapped. I went to the code, and there's nothing that I can see. So I'm guessing it's a race. There's a race condition occurring. So I need to figure out I need to write some test code and test SEI and CLI correctly for the interrupts, because it's causing networking to have some instability. So when you use the network drivers, if the interrupts aren't working, then when you're getting network data in, it's gonna mess up a lot. And then we have over here, these are that's still in test. It's been tested for a little while now because I still need to. The interrupts are kind of a bottleneck on this one here. This one I think is resolved. I have to still look at this and make sure. This one I haven't been able to test because the next network pool I created hasn't filled up, and of course we have all the on the far right we have all the duns. We have all the done stuff there. So. Okay, so I'm going to put that back over there. Okay, so I'm not going to be going through any more of this here because it's probably going to bore people to death. It's going through all that. So what I'm going to do here is I need to actually build a couple more things before I can continue on. So let's bring this back here. Let's go make tools. Similar network flag ready to find. Did I update? Maybe I was working on ipconfig earlier. I might have been. Drivers already defined. I wonder what's going on there. I might have to look into that right away. So line 6. Let's take a look and see what I modified there. It's like I modified something on line 6 there. So this is the basic IP config program. This, I think they have this on the repository opened. I can't remember, but anyways. Let's see here. Basic config. It says, yes. So kernel inc includes it. That's the problem. Network flag is, Okay, let's use the kernel inks one, because that's the one I used when I compiled the kernel, so that should fix that. Oops. There we go. Make tools. There we go. So now the tools are all built up. Good, good. So now I have, if I go /temp debug fs, we have everything here now. And then make showcase bin. And we're going to make the net server bin, and then make net client bin as well. There we go. So now I have net client, showcase, and net server. Okay. Okay. Oh yeah, and if you and for people that are, don't have access to the development thing, if you compile your own programs like this, like I'm doing here, you can, one second here, go to the FTP server. Actually, I'll go to my local host to be easier to connect to. Oh, I don't have it running actually on my local. Oh well, I'm just going to go to the production one. Okay, I'm going to actually have to get the API, my API key in order to connect to that one. But you can connect to the FTP portion to be able to upload files and things. But yeah, there's documentation that I wrote on that. So if you want to be able to upload your own code, because right now using a makefile is pretty easy, but in a sense you could make the makefile use an upload command line program to just FTP upload the files you make and then test it within game. Because after this running, like here for example, I can run showcase now, right? Run showcase, which is it's basically a test tool, right? It's just a basic. Oops, crap. Here we go. Basically just a test tool, right? That's all it is. So, okay, so with that going, so ipconfig we're compiled now because I just need to do that. Okay, anyway, so let's get this out of the way here. So the next thing I wanted to do is, I was working on a unit test as well. Oh yes, this is my unit test tool that I was working on. Not really units, but this basically allows me to test out all the kernel tools. So I have SayPass. It's a very easy thing to look at. Works very good. Let's see. I'll build that right now and show you what that does. So make unit test dot bin. Okay. So now I have the unit test compiled. So let's go unit test. Yeah, so it just basically tests all the kernel APIs just to make sure everything works, and then does a copy string, mem copy, and mem clear, and make sure all those works just fine, right? The one program here that's more unique than the others is my ls, because you'll probably... this is the old version, is it? Yeah, this looks like the old version of it. This is strange. Where's the C version of this? Yeah, we have 5, my code here. Okay. That's peculiar. How is making ls if it's... let me see here. What the heck here? So ls bin So we compile the C. Yeah, it should be called LSC. Where is it though? I don't see LSC here. Because I know I'm not compiling ls.s. Okay, I am going to look up in my build here and see. Because that ls ca, yeah. No, that's not right. That ls program shouldn't be working. That doesn't make any sense. Oh, no, it's not ls. It's not ls. It's cat. Sorry, cat is the C program that I wrote here. Yeah. So cat is the C program that I wrote. This one's actually kind of cool, actually. I think, oh, actually, where's my other one here? This one's actually really neat. So yeah, I have cat bin there. Yeah, so I'm actually going to go make docs. Docs is up to date, is it? No, it shouldn't be. It shouldn't be up to date because docs should be copying. Yeah, copies and copies. So that's great. Make files sometimes don't work as good as you want them to, I guess, because README is definitely not there. Anyways, let's just copy README text to temp debugfs. Okay, so yeah, this is an example of a C program running. So this is the cat program I'll show you in a few seconds. So let's go cat, and then if we go readme.txt, see, it's able to cat the file I just put in there, right? Yeah, this C file is like I couldn't make cat in assembly. I just tried for a while and it was just driving me nuts. I went, okay, F this. I'm just going to make cat in C, and it compiles. I compile this program in C and it just works. So there's a few external, because I have the library tools, right? Because I have a library that's used to make these work. So yeah, so it's a very basic program, as you can see. It's not really technically proper C because you should be doing it open and then reading and then etc. But I just streamlined it with load file. Here, I'll show you how the C library is put together here. So we have kernel S. So in kernel S, this is where get param is. So when we do a call to get param, it comes in like this. So we get a pointer. So we get a pointer to a character, and that's exactly what this returns. This just returns the pointer. So we get a pointer in the F name. So, and then we go to, I think it's file IO. Yeah, this is the load file routine in assembly here. So this essentially loads our file. Right? Very simple. Sets our page. Sets the page. Well, actually, technically the cat program sets it. So if you go to load, if you look at load file here, you have the page. We're loading our file into F500, and then we have our file, and then we have the F name there. So if you look here, we set our page number, and then we do a JSR pop, and then we set our file. We set the file name location, and then we load our API access for file read, and then we set the file control. We load it back in to check the result, and if the result's bad, then we return bad, and and the file size gets returned as well. So the size gets returned back here. If the size is 0, we return 1, and then etc. and then we do put C, and we put each letter. That's why the output's is quite slow there, because we're literally doing console put character continuously. So yeah, so this is cput-c, which just basically sets the character we send in, sets it to the console, right? And this is very, very messy. This is like the worst thing to do, but I was doing this pretty quick, so this actually should be updated and fixed up to not do this. This works, but it's just not the best way. I should be actually, rather than doing this, I should be getting a pointer. I should be getting a buffer, like using the heap, and then setting the heap here, because when you do a get heap, because I did a heap test, I'll show you a heap test program. The heap does work. Here's a heap test tool here that I wrote. So it's able to, Actually, I wrote another tool too. I think, is Hello C? No, it's not the one here. It's another tool I wrote for a lot of other testing purposes, but yeah. Anyways, so this is just okay. Let me take a look here. There's one thing I do need to I do need to test and see if I can make the. Let's go new file here. I could put it in unit test, I guess. This is, actually, let's go intr test.s. So, and echo s is a good way to look to see how things go. So we need that, and then we just need the proc main. And then I need to include kernel inc. Okay, and then we dot proc main near dot nproc. Okay. Okay, so for testing interrupts, see the thing that confuses me a lot is if the interrupts work perfectly fine. If we go to showcase, our showcase program here, because when we do the mouse interrupt, like here's the mouse IRQ here, where we do set and we do clear. This works perfectly fine as far as I know. Clear actually clears it correctly. So I think the best way to determine if interrupts work, because I think interrupts also stop Control-C from working technically. So what I want to do is I want to go SEI. SEI. This should stop Control Break from working. And then we're going to go LDA CIN. And then we're going to go CLI. We're going to clear it, and then we're going to do break. Okay, I want to build this file now. So here is how I can quickly build a program. So make intr test bin. CN is undefined. Is it C? Oh, I know why. I'm importing kernel, not IO. I don't need kernel right now. I need IO. I need IO API, not kernel. Oops. There we go. There we go. Now I got my intr test bin. So now let's bring this in. intr test. So right now Control-C should not work. It doesn't. Enter. Yep. And now Control-C does work. Yep, perfect. So SEI and CLI definitely work. So they're working correctly. I think it is a race condition then that's causing the problem. So what I was thinking of doing is now here is where you guys get to see the first bit of actual Python code in the game engine code. So this is the virtual machine code. This is open. All this code here is in my open source project, part of the game engine. So so the thing is, the problem here is the race condition, because I'm actually thinking of submitting this and seeing how everything works. Okay, so right here is where no, actually that's not the race condition section. It's not there. It is under interrupt. Because this code here is actually where the interrupt gets checked, right? But the code that actually sends in the interrupt, the external interrupt request, is under self interrupt. So this code here, see, before this was actually placed up there, so it would actually queue everything. So all the interrupts would be queued. So that would cause a lot of interesting side effects, apparently. So I'm kind of wondering now if network client, network server will actually work correctly if yeah, I might rebuild that and see what happens. Let's take a look. So the interrupts definitely work as I expect them to here, because Control C is what it comes into self interrupt. So here is an example net server. So here's a network server example that I wrote. It's very, very basic. It doesn't really do too much. I eventually want to create a socket tool to make it available within C for it's easier to code. But now, since this is like this, we're going to need to put SIE here and then do a CLI here. So we set the interrupt, so when this goes through, no more interrupts can come through until this finishes. And now without race conditions, this should technically work a bit better now and should be a bit more predictable. And then where's my net client? Okay, net client code. So net client. So yeah, so net client connects to 3, which is where the server is. Okay, I get it. Okay, I know what to do. Okay, so here, oh, interesting. Net client always had this set. Oh, I didn't have this swapped like net server had. Interesting. Maybe that was causing some of the weird stuff to go through. So net client is perfectly fine then. So net client connects to 3. So I got to send server to 3, and then okay. So we're gonna make net client bin up to date. Net server bin. Okay, net server bin. And then what I'm going to do now is I'm going to go. Shit. So debug.fs to host, and I want to send it to 49.67.30.3. Okay, so now 3 should have it. Okay, so now, so 2 is where I'm going to run the network client. So let's suspend this machine, and then go to 3 where I'm going to run this. I'm going to run the server. So then we just do we'd run net server. Enter to stop server. We just suspend that machine. Press F5. Go back to 2. And then go net client. Okay, so that works that works fine. So it returns back A as it's supposed to. So that's correct. Oh yeah, I can't remember where because I was having issues before with something weird going on. This is why it's kind of hard when you stop development for a while and then come back, is that you kind of tend to lose track on where you are sometimes. Okay, so let's go, let's see here. So, yeah, that didn't, because I was suspended before. Okay, that's fine. But why is there so many, though? Yeah, there's quite a few there. I wonder if I should look into that at all. A lot of these are debugging stuff. A lot of these don't appear. Okay. I'm going to go to the other one here. can see the net server there. It's like you can see like a lot of the VM stuff running. It's quite mesmerizing. Actually, whenever I look through here, it's like, wow, I can't believe I actually created all this. Sometimes it's just like it's such. It's quite amazing being able to, like, it's actually running proper, 6502 code like through a I don't know. It's just. Let's see here. Okay, so there's the net client. So requested remote port access to 23. Then there's that. Yeah, because another beta tester was able to use the network with no other issues. So maybe maybe what I should do is I should just maybe I should create this. Maybe part of this development session should be creating the C API so that network programs can be built in C. And I think that would make things a lot easier to play with and debug. So this is one of the more complex aspects and stuff that players never will have to deal with because it's, well, I guess they could if they want to do more complex stuff. But yeah, so let's do that. Let's create a C API for this. So this is the fun part here. So let's do a make file here. So we have sources. Okay, so file IO. Okay, since this is non-standard C, I'm not going to make it sockets or anything like that. I want to go netio.s is our source file, and that's our library. Okay, so I want to call it netio.s. Okay, save that. Create a new file, netio.s. Okay. Okay, so one of the things that I'm going to need to do is, I guess I'll build the server portion first, because I'm going to probably try to convert this program over first. Do I even use any of the calls from here? Oh yeah, I guess I use print. But I don't think I use anything else. Do I? Anyways, I don't think I use that. Okay, so I need to definitely import this into my netio. Okay, and then we have to export a function call. So I need to modularize this. So actually, I should do, maybe checknet would be nice to have. Yeah, I'm trying to think now. Trying to think on how I want to build the API. Part of me does usually, actually, maybe I should just build the C code first. That's what I usually do. So let's do that first. So let's create a new file. I can't call it netserver.c just yet because I don't want to overwrite my S files. So let's call it something simple. Echo server.c. Okay, because this is the easiest way to probably do this. Oh crap. This always happens. Easiest way to probably do this is to actually build my prototype first in C, and then once I have my prototype, then I can actually work with everything else. So I don't need peak, I don't need anything. So what I need is standard IO and standard lib. I think actually let's just grab all of those. All those should be good. Okay, and so we're going to go void main. Okay, so I'm just trying to think here on how I want to build this API. So for a listen, so we would want to have our, actually I have to define the variable actually up there too. Yeah, I'm going to have to actually make a type, I guess, maybe, or no, I can use the int type for now. Actually, I'll use the int type for now. It should be fine. So int sock, and then we go sock equals listen, and then to listen we need a port number. Let's go 23, and then we need a address of a function call. Okay, and then we go int actually no, void net in. I'm wondering if I should make it. No. Well, I could make C entirely handle it though too. Now I'll look into that later on actually, because I could make C entirely handle everything. And actually, next I'm going to want to let's call it net close, and then we pass the sock as the net close for our prototype. Okay, so let's see what I do for the network server here. So under net in, we send it out to. So I'll need also an external. So I'll need an external function to send stuff out. To do net out, like send strings out. And then LDA and reply. Network reply, and then store that into there. Okay. I'm so tired. This is why it takes so long. Sometimes I have long days at work, and then when I get off work, I just don't have the mental ability to be able to focus and do as much as I'd like to do. Let's see here. So, because this is very similar to the listen commands. We have our port, we have our IRQ, and then we do our listen, and then we do this, and we do this, and then we see what we return back. But I think that's also a problem, though. I just realized is that I believe it will be because the file the descriptors, the socket descriptors are going to be 0 based, but in order to detect a failure, I'd have to return back something in order to detect this is a failure, right? So what I might do is I might send back a 0 on fail, but then just increment and decrement the descriptor when it's being sent in, because that might be the best way to go about it. Okay. So I am going to need a function to be able to send out. So and it's going to have to first for servers. Yeah. I'm trying to debate if this is the best idea or not. If doing that's best. The problem with creating an API is that it's very difficult sometimes, because you have to make sure that it's going to be usable for other people, make sure it's not too complex. While I wouldn't mind having a proper C API. That's just going to take too much time to put together right now. I'd rather have something simple put together, something that players can easily use to compile C programs to create servers and clients and do things quicker, right? So for the moment, this is what I'll do for now as my prototype. So this is the best way to This is what I usually do when I try to develop a new C API, as you'll see right now. So we're going to bring over this. So we're going to go back into ASM, HackerOS, and then I'm basically going to do a CC65 on Echo Server, echoserver.c. Oh yes, I forgot. I have to have the extern calls. That's fun. Okay. So yes. Okay. So extern int listen int port. Technically, it should be a byte, I think. I'll fix it after. And then I don't think it has word as a type in CC65, because I need to make sure that it could be that the next one is a 16-bit address identifier. So I'm going to just go to the CC65 documentation quickly here and take a look. Yeah, so the documentation for C65 is quite nice to have next to your bed when doing these kind of things, because it just makes it easier to see. I don't think it's library. No, it's not library. No, it's actually under CC65. I believe it's under here. Usage now. I thought it was under here that said the types that are available. Because I know there's a location. It's been a couple days since I developed here. Let's try and get my bearings. Okay. That's not what I want there right now. Because I don't think it's called Word. I don't believe that's what it's called in CC65. See, I kind of wish it had. Oh, this is kind of thinking this page is. Oh, this is on my local machine. Okay, this is why none of them are clicked. It's like wondering why none of them are hitting. Why aren't all of these? Yeah. So it doesn't. I don't actually see. Because the function reference isn't going to have the types. At least it shouldn't. Yeah, I thought it was in this one. Okay. Yeah, I don't know where. Can't remember if I can do if there's a type location. Anyways, I don't want to continue boring that. That's getting kind of boring there. Oh, wait a minute. Wait. I just thought of something. Because when I do my calling for the file I/O, I actually use an address for that. So what do I use for that type? What do I use for the file I/O calling convention for my cat program? An int. Oh, I guess if an int works and represents it fine, then that's what I'll do. I'll just use an int for the address. Okay. Extern into that. Okay, and then we go extern. Extern void net close int sock extern void. These will probably change in the future. Right now I'm just getting a basic prototype working. Net reply. Actually, let's see. Yeah, this is a good one to use. Pointer to a character. This way I can keep stuff similar. And data. Okay. Okay, now I can generate a prototype here. Okay. So now if I create this, converting line 16, converting pointer to integer without a cast. What? Oh yeah. Converting a pointer to an integer. Is there a pointer type then? Huh. I'm wondering now. I'm wondering if there's because I know in some languages there is a pointer type, but I don't think there is one here. Because I do need the address of netin. Well, let's just take a look and see what kind of code it generated, and see if it's fine. I don't like having those warnings, but let's just see what echo server s looks like. So here's what C65 gives me. So it gives me my imports. This will obviously won't assemble because I don't have these functions yet, right? But then, it exports. Oh yeah, of course it does. Oh, anyways, so if we go down, you will notice that here's the netin code here, right? Netin. And then down here, you'll see it creates a beautiful pointer to it. But what is? In my code, I don't usually use the bracket though. I don't usually use the bracket for that. It's interesting. And then 17 is our port number. But I don't actually need the port number to be that big though. I wonder if, let's see. Because I can probably save a lot of memory if it accepts byte. Because I think byte is a valid type in C. Ooh, I got lots of errors. Wow. I guess byte is not. I think char is the only one I could use, it seems. Let's just do that and see what happens. Yeah. Int sleep future. Yeah. Let me see here. Yeah, I guess it's just going to be, it would just be a char. That's the only way I can send in a single byte is through a char. I don't like using char, though, for that. But if that's what I have to use, it just looks weird. But, oops. But I guess, crap, I'm so tired. Okay, so char. I have to use char then for that. It's the only way to do that. What's going on here? It's still not compiling anymore. It says implicit int is an obsolete feature. Where am I using it in implicit int? What's line 6? This line, for some reason. Implicit int, and it's line 6 and 7 is where all these issues are happening. But it's not happening here, it's happening... Oh! I'm tired. Okay, let's see. Compile. Hey, compiled. Okay, now if I go back here, I should be able to refresh. There we go. Now the code's a lot smaller. See, as you can tell, it removed a lot of cruft. Now it's just push A. So now this is the port number. This is the port number of 23. Then we push A, and then we do this call here, and then we go to listen, and then this call happens, and this happens here, because I believe push A, and LDY, SPY, LDI, SP, stack pointer. So it's putting that into stack pointer That's strange though, because it's a char now. Sock's a char. Huh. Interesting. And then net close, we LDA. Okay, I get it. Yeah, this is where it's storing our socket, and this is where it's loading our socket. Anyways, okay, so now I want to write these functions quickly. So we have listen, net close, and net reply. So if I go to net IO, what was it called? Listen. Net close, net reply. Okay, so now we can go dot proc listen. Okay, so with listen we have is LDA and LDX. It should be our address here. So what I want to do is as a test, to test the net IO out, we're going to do a STA H out, I believe. What's the IO API? It's been so long as I use some of these. Where is IO API? Yeah, it's H out. Okay, good. H out is what I want. So H out, and then I guess I can do LDA at this point. So LDA, and then STA, C out, and then STX, H out, LDA, A, and JSR pop A, pop A, then we can do a STA H out, or actually and out. This should print. This should basically give me what I want. So then we do RTS. Oh yeah, because I'm returning back a character. So I gotta do LDA. Let's do 0. Let's return back 0, and then send that through. Okay. And then also what I'm going to do is, okay, let's go here, and then we're going to do a test. So let's do this. So if sock equals, actually it's equals 0 in C, isn't it? Yeah, it's equals C and C. I'm so used to so many languages I'm working with, Python, C, etc. Okay, and then we go puts unable to open connection, unable to bind to port, and then return 1. so let's listen, and then the other procs, the other ones are just going to be dummies for now. So proc, net, close, near, and proc, RTS, dot proc, net, reply, near, proc, RTS. Okay. Oh, of course. Okay. Make. So here's the successful compilation here. Of course, here I can find the file, but I fixed it. So now we have a successful HElib. Now I can go down one. Now I got to go rm echo server s, and then go make echo server bin. Returning a value in function with return type void? Huh? This is in the C code actually. It didn't even get to the assembly code yet. So lines 16 and 19. So 16. I didn't modify this line, did I? So, oh no, that's the warning, so that doesn't matter. The line that has the error is 19. Oh yeah, I did add this. Isn't that how I return? Oh. It is equals. Maybe that's the problem. Return 1. Yeah, return 1. That's fine. So it should work. Okay. Nope, same error. Returning a... Oh, wait. I know what's wrong. Whoopsie. Int main. Yeah. Gotta read the error message, right? There. Now I have echo server bin. So now if I run this, okay, this is correct. This is exactly what I'm expecting to be returned back to me. Here's 23, but it shouldn't be like that though, I don't think. That's strange because it shouldn't be. I thought I put a. Oh, maybe I didn't store it out. Anyways, but yeah. So 829 is where the code resides. So actually, what I'm going to do. Did it generate? It did generate a map file. Perfect. I made it generate map files. So this is good. Generating a map file is super good for debugging, as you'll see in a few seconds. So here's echo server map. Here's the C code, how it all works, right? So it looks like it is working though. So I can create this C wrapper pretty easily then. So now if we look down at netin, where is netin? I swear I passed by multiple times. Or maybe I'm not no, it's being exported. Close, put, listen. Yeah. It's being exported, isn't it? It's at 829. So let's do by value. Maybe not. Well, if main's at 831, then 829. Yeah, it's only a couple lower. So yeah, it's definitely there. Okay, so it's in the right place then. So according to my debugging output here, this is correct. It's page 8 and it's address 29 in page 8. That's perfect. And then port 23 is here. So so all the parameters are being passed from C into assembly correctly. So that means this code is successful. So that's good. So now we go back to NetAPI here, and now we can actually use this to, start to listen. So let's do that. Okay. I should port this. I should port that as well. Actually, yeah, that'd be a good idea. That way, programs can actually check for the network. Net check I'll do that for now. I know this is like the worst, absolute worst naming for commands, but whatever. Right now, this is beta development, so things will change once everything gets better, because I'm sure players are not going to want to do certain things like that. But okay, so we have net check, and net check I can basically copy this code here almost. Actually, no, I can't. No. So LDA netseg, if it's... Oh, yes. This is better, actually. Netseg. So what we're going to do is we go LDA netseg, and then that's it. That's all we have to do. So that's easy, because what it does is it just returns back the segment. So in the code, we can determine if the network's online pretty easily. So I'm actually going to test this right away. Actually, let's try this, see if this works. So let's go extern char netseg. So then we go if netseg equals 0, puts network offline. Oops, so used to Python coding here. Okay, network offline. Okay, let's try this. Let's try a quick compile of Echo Server. Cannot create output files. Oh, external, yes. Oh, oops, I didn't recompile the C library. That's why. Oops. Oh, wow. What the heck? This is... Oh, I know why. Go server S. There, good. Okay, so let's try this again. So we're going to go echo server. Huh, that's not right. What's also weird too is that it's just... Why is it... Oh, oops. I didn't do an RTS. Oops. Oh, that's great. Okay. There. Okay, now it should just say... Okay, that's correct. That's the correct action. It says enable the bind network port. That's correct. Now, if I go ipconfig down, network unconfigured. Now, if I go echo server, network offline. Yeah, perfect. And then IP config up. Then we go echo server. Perfect. Enable the bind to port. Sweet. Okay, well, how much time I've been... Oh, over an hour now. Jeez, okay. I might have to... Might have to end the stream at some point soon because it's getting, it's not too late, I guess, but I don't want to continue streaming forever here. Okay. It also says YouTube isn't receiving enough video to maintain a smooth streaming. As such, viewers will experience buffering. I wonder how to fix that. Yeah. Well, I wonder if I would increase the frames per second. I wonder if that would work. Because it says the bit rate here is at 542. But it says YouTube is not receiving enough video. Not receiving enough video to maintain. Huh. Yeah, I wonder. Anyways, okay, let's see here. So now we have the listen. So now we have the net. So now we have net seg equals 0, which is perfect. That works just fine. Now we just need to make it for the sock will actually listen correctly. So we go to net server here. We go so we just store the port into net port. Oh yeah, net, and then net IRQ and net IRQ plus 1. Yeah, okay. So we have first is we have the as we store X into net IRQ and then STX net IRQ plus 1. Then we JSR pop A. Then we go STA net port, right? And then LDA. I believe it's net listen. I can never remember my n listen. So LDA n listen, STA n CNTL. Is it n CNTL? No, net CNTL. Consistency. Net CNTL. And then we go LDA net CNTL. And then instead of doing LDA 0, we just return. We can return LDA directly back. So listen command, when the parameters come in, we set the network IRQ location, and then we have our JSR. We pop A to get our network port. We store the network port in. Get and listen. We do that. And we RTS back. This is actually more streamlined than this. Who knew that C would be more streamlined? Okay, and then not equal means we have an error. So if it's not equal to 0, then we have an error. Oh, but we want to return. Actually, yes, that's true. Okay, so not equal means we have an error, right? Yes, actually, so we don't want to do this actually. So we have to go BNE plus. Is it? Yeah, BNE plus. Okay. And then we can go LDA net IDX. I believe I have it as right. Net IDX. Yep. And then we can just do RTS. That's all we need. Because we need that we store the the index in there. Oh, actually, oops. Actually, yeah. LDX net index. And then INX. We have to make sure it's not 0 based. And then we go transfer X to A. There, problem solved. Okay. Now, if there is an error, then we just go, and if it's not equal, so it's not equal. Actually, oh, there. If it's not equal, meaning we don't have a 0 anyways, we just return back, right? Or no, because if it's not equal, crap. That's what we check for errors. So we have to go LDA 0, and then RTS. We have to do that for now, at least, until I make a proper error handler system for network stuff, which I'll have to do, I guess, eventually. So for now, that should be fine. So this should start a listening port now. So, and then next, so that's the start section. So now we have to do the net stop. So net stop. So if we look at our C code again here, it just sends it in as A, I'm quite sure, under net close. So if we go net IO, net close, we just need to, so it's in A. So I think that's what I already have to worry about. Yeah, so STA net IDX. So STA net IDX, and then I think LDA and close, and then STA to net CNTL, and then LDA. I don't think you need to do LDA for that, do I? Oh, yeah, I guess I should. Oh, end stop it's called. End stop, and then LDA net CNTL. But for my close, I don't actually care here, to be honest. So, okay. Actually, I'll do this for now. Yeah, I'll do that for now, because I'm probably going to update the code anyways at some point, so let's do that just for the moment. Okay, and next, we just need to do the net, the end reply. So, the net reply, this is for the server replying back to, this is for server. Oh, my stream's back to healthy again, that's great. So this is for replying back. Okay, so this is the fun part here, is that I need to basically load yeah, actually I wouldn't mind compiling this again, because I think this is a string, right? I think it sends it in a certain way. I want to do something else for, I'm going to do this. Okay, and next I'm going to go make the S, and then I need to find echo server S. Okay, yeah, so here's the hello world stuff here. So yeah, so what it does, it goes LDX and LDA LDX. This basically equals our, I guess hello world is actually 3. So LDA LDX is just the pointer. So that's perfect, actually. That's perfect. So net reply. So we have our that. So what I want to do is I want to go PHX. We're going to push. Actually, we're going to push Y. And then we make sure we pull Y afterwards. And then we're going to go LDY 0. And then we're going to do a LDA. Ooh. I just thought about that. Yeah, I need to put that into a pointer actually before I can even do anything. So I need to import ZP. Import ZP PTR1. If I don't do that, then I won't be able to do it properly. So before we even do any of this, we need to just we need to do a STA PTR1 and STX PTR1 plus 1. So we have our code there. And then we do that. Then we can do an LDA PTR, actually LDA PTR1 comma Y. Yeah, because that should be, yes, that should be correct. This should get me what I want. Yeah, okay. So next So we have that. So we do our LDA, PTR. Oh no. Actually, no. We need brackets. Yes. It's a pointer. It's not reading directly. Right? Yes. That's what I want. I want in brackets. Yes, I want it in brackets. It's a pointer. Okay. So if we have that, then we can just do STA. I think it's net out, right? That's what I have. Yeah, net out. So STA net out, and then we just do net out constantly until we get a 0. We don't need the 0. The 0 though. But yeah, I should actually do something like that then. I'll do that later though. For now, I won't allow nulls. Just for now. So we're going to do a BNE. So if it's a 0, then we're done. If we're not, then we're going to go BRA back. And since I'm doing BRA and a few other things, I got to go dot CPU type. Or no. I think it's set. Yeah, set CPU. That's it. 65 CO2. Okay. And then we're done. Actually, nope. Done is down here. So we go back. Oh, oops. I made a boo-boo. I and Y. Increment Y. Then we go back. And BN. So it's not equal to go up. Okay, perfect. That's good. And then down here, we do an LDA. And LDA n reply. N reply. And then STA net CNTL. CNTL. Right? Net CNTL. Oh, weird. And then we have our RTS. Oh, you know the big problem here is this. Because it's not doing an RTI. This has to be an RTI. So I actually have to create another code to make RTI work easier. Because if this doesn't RTI back, then it's gonna mess up. So this is probably a good reason why I should manage the callback stack myself on behalf of the player code. Where when you do listen, the C code just registers this, it registers the function, but it doesn't do anything much more than that. So then the C function always takes hold of the handles. So the IRQs are always pointing there. But I'm wondering now what the best way to. Yeah, because I'm just trying to do a quick and dirty socket library for now until I can get just make things make testing easier and things like that, right? So. Yeah, but I do need an RTI function to be available to me there. So, actually, let's see here. So I think for now, what I'm going to do is I'm just going to just easily I think I'm just going to call assembly code directly in. in there, because you can put inline assembly, so I can just do my RTI directly there. So that way I don't have to worry about it at all. It'll just work the way I'd expect it to. But okay, so this should work. So if I do ASM RTI, that should work. At least for now, that's how I'm going to have to do it. So let's see if the inline assembly did it correctly. There, so now we have an RTI. Perfect. We have an RTI now, but an RTS as well, which is kind of annoying. So I'm probably going to do some magic later on with the coding, so that doesn't have to happen. But for now, it's just kind of a fact of how I'm going to have to do this. Okay, so now what I want to do is I actually want to do cget C, I believe, is what I want. It is cget C, right? Huh. It's been so like I don't code in C as much as I should now. Maybe I'll have to get more into C programming at some point. I don't know. I think it's ConIO. Yeah, ConIO is the one that has cget C, and I imported ConIO. Yeah, I did. Okay, so after we bind the port, I'm gonna go puts listening on port 23. Press enter to stop. And then we do cget C, just like that. I thought I did cget C. Oh, I probably couldn't do cget C, maybe. I might not have been able to do that because I have it I had it before, I thought, in my other code, but I don't have it here. That's my read method. So I don't actually have, yeah. I thought I actually did have a way to do input. Read. Okay, so I didn't actually update all of my stuff here then, it seems. Let's see. Let's go standard IO. Yeah. Okay, well. Whoa, there's actually a fly here, which is strange. The weather's not that warm here. Shouldn't be. Okay, well, I'm going to have to quickly make a C get C, I guess. But the problem with C get C, yeah, no, I can do this. C get C dot S, C get C. Okay, so dot export C get C. Dot include dot slash IO dot inc. The file looks like it's going crazy, like it hasn't had food for. Anyways, so dot proc underscore C get C. Here, and proc. Okay. The thing about C get C is that I will have to use my new API that I recently created. So it would allow more than just enter technically. Because I actually added a, see here, so keyboard flags. So it's going to be, so I need this code. And then I can do LDA cin. So what I do is I do this, we go LDA, keyboard flags, we aura it, and we store the keyboard flags back, and then we do LDA cin. Then I have to push A again, and then we put the keyboard flags back. Or actually, dot import temp1. And then we want to store the keyboard flags into temp1. We do aura, and we store the keyboard flags back. We push A, and we do LDA temp1. And then we do STA KBD flags. Then we do pull A, and then finally our RTS. The problem with it, I want to probably have to move out the keyboard flags into a separate file though at some point, because this is just not going to cut it. But at least now I have a temporary C get C. So let's go into cd clib, make file, and go C get C dot S. Make keyboard flags is undefined. Is that special to Showcase? I guess I didn't add keyboard flags into my IO. I thought I did though. Or no, I re-add something. Yes, that's why. traw. This is why. There, it's called tcntl. So LDA tcntl tcntl tcntl, and then aura traw. Yeah. Okay, save it. Okay. Yikes. Okay, so I got quite a few different errors now for some reason. Don't know why though. Unresolved startup. C get C referenced. Oh, I know why. There we go. Address size mismatch for temp1. Exported from 0 page. Oh, that's, yeah, it's supposed to be import ZP, not import. That's why that won't work. It's a bit of an annoyance, but... There? What? Oh. Oh. I need to... Yeah, of course. Okay. Come on. Got it. Okay, here we go. There we go. Sheesh. Okay, so now cgetc will work. So let's find out what happens. It works. Yay. That's awesome. Totally worked. Yeah, and net close even most likely closed it as well. So, well, let's check our network segment and see what the network segment actually has. This other part of the debugging as well, right? So we go E00, E00.E00A. Okay, so here is the IP address. It says 1, meaning it's technically still listening. I wonder if that's just a okay, let's try something here. So I need to take a look at... So if we go to IO API, we can actually work with it directly. So let's go... So it's 7.1, right? So let's go FF7.1. Right now it is 1. That's what I want it to be. Okay. And then FF7.5. Okay, so FF7.5. I don't know why it's FF though, that's weird. Oh, there was an error, most likely he's trying to stop it, I guess. So let's put 4 into 7.5. Okay, and then FF7.5. It says FF still. That's not good. So this is 1. So there's something going on here. Let's take a look at the VM backend and see why it's not stopping. No, it's not telling me why it hasn't stopped. That also means that technically, if I tried to listen again, it should fail. It should. I have code that checks that. Right? Yeah, I do. Oh, I know what's wrong. Remember, it's 0 indexed. So now 754. There. Success. There. It's closed now. Perfect. Okay, now Okay, so that's good. So what my thing is that net close is actually not lowering the socket properly. That's the problem. Net close isn't lowering the socket. So net IO, when we do a net close, we don't want to just store A into there. What we want to do first is we actually want to do TAX, INX, or actually, no. Let's try this. Decrement net IDX. That should work. So we store it in there, we decrement it. There. This should actually work. Now I have to just rebuild, recompile the clib again. Make echo server bin. Okay, it was successful. Now let's try running echo server again. Okay, now technically if I go hgmon now, there should be no, oops, this is why I do this first. Enter. Perfect, it works now. It works. Okay, awesome. So yeah, so now the net API one works. Okay, so I think now it's getting about 10 o'clock. It's getting kind of late. This stream's almost going to be 2 hours long if I'm not careful. I don't think anyone's going to watch it this long. I'm probably going to make shorter videos at some point. So yeah, that is basically the process and an easy part. So I'm going to go status here. I have a lot of things I need to modify, so let's go svn add server asm os c lib net ios os cget cs echo server C. Echo server C. Okay. Okay. I didn't modify any of the Python files at all. Nope, I didn't. Okay, good.